So this is part 2 of the circuits vocabulary, and we're going to start with current. So current is how much electricity or how many electrons go through per second. So when you're thinking about this compared to water, it's not how fast it's going, it's about how much water is going through per second. So here on the right, I have a smaller river that, oops, a smaller river that has some water going through it and it's moving fairly quickly, but there isn't that much water in comparison to this really huge, really deep river. And this river has a lot of water going through it per second. And so if we were talking about this in terms of electricity and electrical current, this would have a much bigger current because it just has more water going through it. Even though this is a small, quick river, it doesn't have that much water going through it. So it's a little bit weird because it's counterintuitive to your normal thought process for what current is. But we're really talking about how much water or how much electricity is getting through per second. Now, current is weird. The variable for current is capital I, and the units for current are amps. Or capital A. So this one's a little bit weird just because you have current that starts with a C, but you're using an I for the variable and an A for the units. And so you'll just want to make sure you write that down so that way it's not confusing when you go to do these problems. The second vocabulary word here is voltage. This is nice because the variables and the unit is V, so your variable is voltage and the units are volts. And this is just how hard the electrons are getting pushed through the wire. So I could push on these electrons to get them through. I could push them gently, or if I pushed really hard, it would make sense that I would get a lot more electrons through. And so that voltage is just how hard are you pushing on those electrons to get them through the wire. And the last vocabulary word in this set is resistance and resistors. So resistance is how we measure how much, like how hard it is for electricity to go through something. And a resistor is something that is going to have resistance. And so these over here, these are called resistors. This is what they look like. They're very small on average. And you'll see them on circuit boards. You'll see them in all kinds of stuff that has anything to do with electronics because it makes it harder for the electricity to go through it so it doesn't go through too fast. Some other examples of resistors are the electric stove tops, where when you put the electricity through it, it gets really hot. Because it's really hard for the electricity to get through, it'll get hot. And then the same thing with like heaters. And then if you're looking at these and you can see all these colors on here, that is how you know how much resistance a resistor has. So that's what this is over here. Is there's essentially a code for what each of the different stripes mean, and each color is a specific number. And so what's nice about this is you don't have to put numbers on here, you just have colored stripes. So that way it's really easy to tell what is what, and you don't have to get out a magnifying glass to read the number. And then lastly, we have light bulbs. Light bulbs are also a resistor, especially this middle part here that lights up. That's called the filament. When you put electricity through this part of the light bulb, it gets very hot. And when it gets hot, it glows, and then the light is turned on. And so if you turn off the light bulb, then that'll stop glowing so hot. So thinking about resistance again and the biking analogy, if I am riding my bike through sand, it's going to be really hard to get through versus if I'm riding my bike on concrete or asphalt, where it'd be really easy to ride my bike on the road. So that resistance is just making it harder for the electricity to get through. All right, so what you're going to do next is you're going to go back to the same PhET simulation. And I want to know what happens to the current when you change the resistance and what happens to the current when you change the voltage. And you'll just need to complete these two sentences. When the resistance increases, the current will. And when the voltage increases, the current will. And let's take a look at what you're going to do that. So you'll go back to the same simulation. It's called the Circuit Construction Kit. And so if you're Googling it, just Google PhET circuit construction, and you'll come across this simulation. So I'm going to get out a couple wires again. I'm going to get out a battery. And I'm also going to use a resistor. And so I'm going to make a circuit. So remember, a circuit, I need to make a complete circle. And I'm going to hook up my battery. And I will notice that the electricity is starting to flow, which is perfect. So to change the voltage, all I need to do is click on the battery. And once I click on the battery, it'll get a yellow box on it. And I can drag this little bar to change the voltage. And then I can see what happens to my current. I can do the same thing with my resistor. I click on the resistor. I can change the resistance of my resistor and see what that does to my current as well. And just remember that current is going to be how many electrons are going through per second, which in this case is going to correspond with how fast they're moving. So the more current, the faster it's going, the more electrons are getting through. Hopefully that's clear, and good luck.